So this one says rank the following in terms of decreasing vapor pressure. So decreasing means biggest first, the one with the highest vapor pressure first. And if you go back a few questions, you'll learn, or you'll see again, that vapor pressure is inversely proportional with intermolecular forces. So the one with the highest vapor pressure is the one with the weakest intermolecular forces, because vapor pressure is essentially measuring the gas above the liquid. So if you have low intermolecular forces, the molecule is going to be more easily vaporized. You're going to have more of it in the gas phase, and therefore you're going to have a higher vapor pressure at a given temperature. So here we have not already drawn these Lewis structures like in the previous two examples. So we need to look at the strongest intermolecular force in each of these things. So if we look at C6H6, it only contains carbon and hydrogen. So generally speaking, the strongest intermolecular force is your dispersion force. C3H8, same thing. It only contains carbon and hydrogen. So this is going to only have the dispersion force as well. And then finally, we have CH3OH. This has an OH on it, an O directly attached to an H. So the strongest intermolecular force here is going to be hydrogen bonding. And just so you know, this is benzene. Used to be a common organic solvent. This is propane, the stuff you'd use at a barbecue grill, and this is methanol. You might find it in windshield washer fluid, for example. So these are, pretty common molecules here. So if we look here, we want decreasing vapor pressure, which means we want the one with the biggest vapor pressure first, which means we want the one with the lowest intermolecular forces first. Vapor pressure is the only one that's inversely proportional to intermolecular forces. So we have two here with only dispersion. So we're going to go by size. Now you can look up the molar mass, or you can just look simply, this has more carbons than this. Since carbon is much more massive than hydrogen, the carbon is going to make more of a difference. So if we look here, this is 78.11 and this is 44.10, but you don't necessarily need to look them up. This has 3 hydrogens or carbons, this has 6 carbons, so this is going to be the absolute greatest vapor pressure because it has the lowest molar mass and therefore the weakest dispersion forces. So C3H8 is going to be greater than C6H6 benzene, which is going to be greater than CH3 OH, methanol, because methanol has the strongest intermolecular forces, hydrogen bonding. So this is a little bit confusing because the biggest vapor pressure is the weakest intermolecular force. So this is actually the weakest intermolecular force, even though it's the greatest vapor pressure.